So my name is Regacho. I'm a student along with Matsushita, also a student of research advisor Ceniza-Canillo. So we're both, Ali and I are both enrolled in Bachelor of Science and Computer Science in a wonderful university, University of Psychology. So as students, we wanted to kind of, in our latter years in university, we really wanted to have this thesis that could really help out. So as myself, I basically kind of conjured kind of created like 11 topics. All of them was rejected. Either they were too hard, too complicated, or they just took too long to make. So, and in the next slides, we will show you why we chose to pursue automated identification of disaster use for crisis management using machine learning. So, research problems. So, back in December of 2021, Typhoon Rai, known internationally and locally known as Typhoon Odette, swept through central Philippines, the place where I live. And many news outlets reported the matter, including phony ones, and fake news. Also, fake news regarding the typhoon started spreading more than legitimate news. But this became a very legitimate, a very kind of important topic because around that time, like because of the typhoon, the damage was disastrous, so immense that basically the entire city was not able. There was no electricity, there was no water, and because there was no electricity, there was no internet. So a lot of people were clamoring to find out what happened in Central Philippines, what's going on. Because of this, a lot of phony news outlets really capitalized and tried to really kind of change the narrative. They kind of really wanted to just take advantage of the narrative, just basically share propaganda, especially in social media so, uh, where fake news spread like wildfire. So because of this, um, I basically introduced this topic. She was influenced in her home country, Japan. She was influenced basically in Japan. They have this automated system that basically identifies a specific area which where news has sprung up. Basically by just checking social media. So basically checking Facebook, checking Twitter, checking Instagram, and the respondents are sent right away. This is automated. So we wanted to kind of like make that as well through through news outlets. So so in this presentation, I'll basically be discussing our steps and how we pursue them. So next, so obviously we have chosen natural language processing as the way we pursue this project or thesis. Not only is natural language processing helpful, um, it's also kind of something that our research advisor really specialized on, so we can get a lot of help. And this is new to us as computer science students. We are interested in any kind of algorithms, any kind of computer science thing. But natural language processing was new to us, yet it was around us every day. So basically, each and every day that we do, every web page you see, there's always natural language processing. So it piqued our curiosity basically. So we wanted to pursue this. And in natural language processing, there are a lot of techniques that you can use to basically process natural language. So we have here sentiment analysis, we have name entity recognition, we have text summary, we have topic modeling, we have text classification, we have keyword extraction, we have lemmatization and stemming. So amongst this, we have chosen to choose text classification and lemmatization since majority of the data sets that we will be analyzing is text, and we chose lemmatization just to simplify the method of extracting those data sets to make sure that the analysis, the calculation by the computer goes as smooth as possible. So text classification, so we're going to discuss text classification. Basically, very simple method. It organizes large amounts of unstructured text, basically unclassified data that do not have a category. So basically, it's just all over the place. It's random, very random. And through text classification, it basically sorts that data. So let's say you have a massive paragraph, let's say 2,000 word paragraph. That's a very long paragraph. And you want to know which words were which the categories of all the words to make it simple for you. So you want to know which which words are first words. You want to know which words are for education. You want to know which words are for the specific categories. So text classification basically sorts all those words. That's the large amount of text to make sure that the computer basically sorts that and makes it easier for it to find which word. And next is lemmatization. So the process of reducing different forms of a word to one single form. So there are a lot of ways. There are a lot of how to say this, like words that have the same meaning essentially. So let's say the same, similar, and they're practically similar. They're the same. So basically, lemmatization just kind of simplifies that and makes it into just one word. So you can see, we see an example you can see here. And also like as I said, the same and similar. So you could just same and similar, basically the same meaning. So you could just make that into one word. So that the same is making it similar, it's basically the same meaning. So that you wouldn't need to process all these words. So the same is two words, and similar is just one word. So it makes it easier for the computer to process that. So that your data sets wouldn't be as confusing. For the computer also helps with, when you're storing data in the database, you want to store as much data as possible and you want to be efficient with the amount of data you will be storing in that database. So basically reducing that into its simplest form makes it a lot easier, not only for the computer to understand and to just pick that word and basically calculate and analyze that word, but also in storing the data. I mean, it makes it more efficient in the database. And next we have here the classification model. So there's a lot of classification models to choose from. So in our research, we decided to pursue multinomial name base, random forest, logistic regression. So let's start with multinomial name base. So name base in its own is one algorithm, and name base has three sub. Basically, that's three. So we have Bernoulli distribution, we have Gaussian distribution, and only shows we have multinomial distribution. So it is a probabilistic learning method that is mostly used in natural language processing. So we have this formula, very probabilistic. So why did we choose multinomial name base? So we actually tried Gaussian name base, and it kind of produced not the results that we were looking for. It wasn't as high of an accuracy as we wanted. So around the two, we only choose to Bernoulli name base. So around the two, multinomial name base had the better accuracy, had the better scores. So it chose multinomial name base. So why multinomial name base? So very useful when your data set is distributed multinomially. So this algorithm, especially where it comes to classification stuff, basically understanding that it enhance the most amount of this and basically analyzing that from there using this formula. Next, we have random forest. So it's a machine learning algorithm that helps us when we this problem for decision trees. So random forest is basically a forest of decision trees. So in this, it shows that it is also known as the random forest classifier, and it's very prominent as a classification because you can use it also in regression. So it's very suitable for both classification and regression tasks. It has a really high accuracy because it cross-validates across different decision trees, and it can handle missing values, and it can handle a large portion of data sets with high accuracy, and it's very fitting in our research. There's a lot of different news outlets that you can choose from. There's a lot of different news outlets. Not all news outlets kind of report the same way. So it's a lot easier for us and a lot easier for the computer to analyze those different news outlets, especially the ones that are not legitimate, especially the ones that are phony. It provides a very accuracy in identifying the legitimate news articles from the fake ones. So next, we have logistic regression. So estimating the parameters of a logistic model. It's quite useful. It's quite useful. So basically, predicts the probability, yes or no. So basically, just yes or no. So there's a lot of applications that we can use logistic regression, and it especially helps us, especially in identifying legitimate news article from a phony one. So let's say you have a ton. So basically, it just says how accurate this one is. So based off of that, you can identify if this one is factual or is it false. You can identify which parts of it is factual, which ones are kind of sketchy. I don't know. It can be about that part, it can be biased and stuff. It can be leading towards something else, not exactly reporting with the actual news that should be reporting on. So you can basically identify that using this classification model. So next is combination. So as researchers also wanted to experiment on algorithms as well, so we decided to combine all of those classification models. So basically, combination is just a combination of multinomial base, random forest, and logistic regression. So basically, we wanted to know the result. Let's say multinomial has its own result. Random forest has its own result, and logistic regression has its own result. So we wanted to know, what if you combine all these three? What results would we get? Would it be higher than one of these three, or would it be lower? Would it be better? Would it be more consistent in terms of identifying these disaster units? Or would it flop? Would it be just a failure? So we wanted to identify that as well. So next is we have bag of words. So we use bag of words to basically collect data and also to identify the amount of words of a specific word in a specific article. So we have count vectorizer. Basically, it discounts unique words. We have, let's say, example that you see, the quick brown fox jumps over the lazy dog. So it just counts the amount of words, amount of one word in a specific sentence. So we have two does, one brown, one fox. And TF-IDF is a bit more specific in terms of the words that it counts. It's basically similar, but not exactly. Basically, highlighting the ones which are more frequent in a document. So in a document, there's always those words that are very frequent, but not necessarily helps out in terms of giving more accuracy in the sentence. So let's say words like in or an or an. Those words are those words are frequent. You can find them a lot, but those words don't necessarily help out in improving the accuracy of a given sentence. So basically, TF-IDF just highlights the words, and basically TF-IDF ignores those words. Make room for the words that give more value in the calculation of the study. So next we have word count. So we have shown here the word count of our results. So for here we can see the legitimate news articles. So out of the processed 80 news articles, amongst all of those 80 news articles, in the legitimate news articles, you can see here a lot of social media, public residents, city, barangay. So basically, it focuses on the area. So barangay is basically, you say it's a square. It's where it's like a city, but if you divide a city, you can divide it by barangay. That's how we do it in Philippines. So barangay is basically a specific place. So here in Cebu, where I live, barangay is a specific name. So basically, it's a way to identify specific locations. So one barangay could be in two barangays could be in the same city, but they're in different locations. So one barangay could be in the north, another barangay could be in the south. So it's basically this word cloud identifies a specific town, specific barangay, specific area, which heard, especially specifically that that type of word. So let's say a tree fell Because of the strong winds, the tree fell on a house in his veranda. So it reports of that. So there are multiple injured in this specific area. A tree fell, or the road has been blocked with debris and stuff like that. So you can tell that it really specifies. It's really legitimate, and it really tackles the news. It really tackles the topic. You can see a massive difference in the legitimate news article word count. So in the legitimate news article word count, there's a lot of politics. We have the vice president. We have campaigns. We have Daniel Robredo. She's running for. She ran for president. We have Bongbong Marcos. He also ran for president. We have Rappler, not necessarily known for its, you know, for its accuracy in terms of providing relevant news. We have commissions. We have elections. We have senator. So it's way towards politics. It's not necessarily talking about the disaster. So you can tell like what kind of news this articles are producing. It's way toward politics. I really want to delve deep towards politics, not presidential candidate. So it's not necessarily the reporting on the news, reporting on propaganda, about politics and stuff. Not necessarily what you want to read in terms of if you want to find out about the damages, the amount of casualties, not what you want to read because it's all about politics. It's all about just basically improving the image of these people that are running for politics. So you can tell that they have this agenda that they want to kind of push towards the citizens. Because of this, it's not necessarily something you want to read. So next is confusion matrix. So we have the data sets. We have identified all the words using datasets. We have text classified all of the words. We have used lemmatization as well. So in confusion matrix, basically when all of the data sets goes through all the classification models, it also gets a confusion matrix. So the confusion matrix identifies the true positives. It identifies the true negatives. It identifies the false positives. It identifies the false negatives. So these variables are important in identifying the accuracy of a given model. So let's say that it's not as balanced. Let's say it's not balanced. It's not this way. It's a lot of true positives. A lot of true negatives. There's about 24,000 true positives, and it's 1,100 true negatives. So it's really good at identifying the right ones and the non-factual ones. And there are times where made mistakes. So 429 in the 15 and 104. There are times where it's not exactly as accurate as it could be, but that's fine. As long as it's the majority, it's actually identifying the fake news from the relevant one. And so from that confusion matrix, we have here the F score and F measure. So this is a measure of model's accuracy of the data. So in the F score and F measure, basically it's the formula and you use those variables, the true positive, true negative, false positive, false negatives. It's the formula that identifies its accuracy, it identifies its precision, it identifies its recall, and also it identifies its alpha score. So this helps in really identifying which classification model did the best job. So the logistic regression have the higher accuracy against, like, let's say, multinomial base. And you can tell that the logistic regression is a better job in identifying fake news from the legitimate news. Let's say random forest did a better job than logistic regression. So let's say, okay, so random forests have higher accuracy. So we can basically conclude that in that case, random forests have the best accuracy, therefore random forests really good in identifying fake news amongst the others. So you can also get the positions. You can identify the same way. Vehicle, you can identify the same way. Plus, you can identify the same way. So next, our conclusion here, right around the end. So basically, we can show here our combined model for the VLW, also the TF-IDF. So the results are 91%, 91.7% for the combined VLW model and 19.18% for the combined TF-IDF model. So the combined model actually, in our study, we have not shown the table, but actually the combined model produced the best results, the highest results in terms of identifying the accuracy, the precision, the recall, and the evidence. As you can see here in the precision, it got an 88.33%, it got a 94.64% on the recall, and yeah, for the F1 score, it got 91.38% for the F1 score for the combined TF-IDF model, and for the VLW model, and for the precision, it got 86.89% for the recall, it got 94.64% for the wait, this is I'm sorry, 86.89% for the precision, it got 94.64% for the recall, and for the F1 score, it got 90.6%. So you can basically tell that combining all of those models, combining linear regression and logistic regression. Oh my God. I'm sorry. So combining logistic regression, combining random forest, combining multinomial big base, it kind of showed that combining all of those really produced the best results. And so combining all this classification, although they produce really high results on their own, combining all of them really gives a really high result in identifying disaster. So in terms of using that for the automation of identifying disaster use for a specific disaster, this one produced the best results. So because of that, it is the best one to use in the automation process. So that's it for my presentation. I hope you guys learned a lot. I really did a lot of work, a lot of hard work, and really doing that thesis, that research. So I hope you guys really enjoyed and learned a lot about our process of identifying disaster news from, from those